everybody, and welcome to Josh's Coding Hub. Today I'll be taking you through the second edition of the computer science. Today, in computer science, we're going to be covering hexadecimal, binary, and denary. So without any further ado, let's get started with today's class. Let me start today's session. So in this lesson, we're going to be going through the three main types of languages that the computer uses to understand what we wanted to do: binary, hexadecimal, and denary. So we're going to be starting with what is binary, an example of binary. Then we'll do the same for hexadecimal and denary. And then the last two slides will all be about how to convert binary, hexadecimal, and binary, denary, binary, and hexadecimal, binary. So let's get started. What is a binary? So basically, binary is one of the languages that a computer uses, like I said before. It is written with zeros and ones. One is the lively value. One is the value that is normally classified as lively, and zero is the null value, the none value. Binary are written in series of 8 numbers. So a binary, for example, would be this: 1001, 1101. So in this binary, there are 3 zeros and 5 ones. 3 plus 5 is 8. So this can be classified as a binary, with written as only in zeros and ones, and has 8 numbers. They're not written in 8 numbers, but they're written in 4, 4, which make up 8. So that is a binary. Then to hexadecimal. Hexadecimal is one of the languages that a computer uses. Unlike binary though, hexadecimal is written in a series of numbers and letters. Numbers below 10 are written as themselves in hexadecimal. So as you can see, 1, 3, 1, 9, 8, they're all below 10, so they're written as themselves. But numbers above 10 are written in the alphabet with A representing 10 and so on. A representing 10, B representing 11, C representing 12, and so on and so forth. That's why you see all of these A, B, D, A in hexadecimal. But what if you want to represent a number above 36? Well, then you just have to use multiple hexadecimal numbers above 10 to represent that number. So this is an example of a hexadecimal, 9D. So 9 is below 10, so it can be written as itself. And D represents 13, I think it is. Then our last one, Denary. Denary is another language that a computer uses. However, it's the least used language. It's not that famous like the other languages, binary and hexadecimal. It's written in whole numbers, so it's not very easy to understand. Because of its difficulty, that's why it's the least common language. And in my opinion, it is the hardest language for the computer to understand. I found it very hard to understand Denary, so don't worry if you don't understand it at your first try. So, wait. So this is an example of a Denary, like I said in my previous slide. It was only written in whole numbers. So this is written in whole numbers, 155. So now this is the important slide. You should be taking notes and taking a picture of this slide. This is This slide and the next slide are the most important ones. Converting binary into hexadecimal. So let's take the binary number we took earlier. 10011101. Now, remember what I said about binaries with 1 being the lively value and 0 being the none value? Well, this comes into use while converting it into hexadecimal. Okay, so 10011101. So our first step is to write 8421 below these values. We write 8421 is what we write every single time while converting. It's like a rule in computer science. So I don't think I'm just making up random numbers. It is a rule. And if you notice, it is doubling every time. So that's why that's the reason behind 8421. So then, when we see 1, the lively value, the number below 1, we keep in mind. Then we see all the numbers below 1, so in this case, below 1 is 8, below this one is 4, below this one is another 1, then we add them together, like you can see here. 8 plus 4 plus 1 equals 13. Then here, again, lively value 1, below 1 is 8, and below 1 here is 1. So 8 plus 1 is 9. So we can, as 9 is below 10, we put 9 as our first value of the hexadecimal. Then we have 13 to deal with. As 13 is above 10, we use the ABCD rule. A is to 10, B is to 11, C is to 12, and D is to 13. This gives us our answer D. As D equals 13, we can put D as the second value of the hexadecimal. Now just to clarify, the reason that we don't add the number below 0 is because it's a null value. Any numbers below 0 we aren't supposed to add. So we've covered converting binary into hexadecimal, but then how can you convert hexadecimal into binary? Well, let me explain. Hexadecimal equals 9D. So first we can get the D as 13 using this rule. D equals 13. So first of all, we separate the hexadecimal number, putting 9 to one side and D equals 13 to the second side. Then we list out 8421. Remember, it's a rule in computer science. I'm not making up random numbers. So we need to have a combination of these numbers make up 9. 8 plus 4, that's 12, too much. 8 plus 2, 10, 1 off. 8 plus 1, 9. So we put 1, because so now 8 and 1 are the lively values. Because 8 plus 1 is 9. These are the values we're using. 4 and 2 are garbage values. We aren't using 4 and 2 in this problem. Then we put 0 below the garbage values of 4 and 2. But then the lively values of 8 and 1, we put 1s below. So 1, 0, 0, 1. We got our first series of binary numbers. Then we got D equals 13. So we do the same thing. Oops. So we do the same thing. D equals 13. We list 8421 below, and we find out the combination of numbers. 8 plus 4 plus 1. That's 13. So 2 is the garbage value here. We put a 0 below 2. But then 8, 4, and 1 are the lively values. We put a 1 below them. 8 plus 4 plus 1 is 13. So now we've got a binary. 1001, 1101. So now we've covered converting binary into hexadecimal and hexadecimal into binary. Time for our next slide. Converting binary into denary and denary into binary. Okay, so we will take the same binary number as before, 1001, 1101. Now, this is similar to hexadecimal, but a bit different for denary. We start with the 8421. We start from 1 and we double. But instead of doing 8421 again, we keep on doubling. So we get 1, 2, 4, 8. 8 double 16, 16 double 32, 32 double 64, 64 double 128. Then we look, where are the garbage values? 0, 0, and 0. The numbers below 0 we cancel off. Cancel, cancel, cancel. Numbers below 1 are the values we add. So 128 is below a 1, so we add that. 16 is below a 1, so we add that. 8 is below a 1, so we add that. 4 is below a 1, so we add that. And 1 is below a 1, so we add that. If we add them all together, we get 157. So the denary of 1001, 1101 is 157. But then how do you convert this 157 back to binary? Well, it's pretty simple. You list off the numbers 1, 2, 4, 8, 16, 32, 64, 128. You need to find the numbers that will add up to 157. The combination. This will be 128 plus 16. That gives us 144. 157 minus 144 is 13, meaning we have to find a combination of 13 within these numbers. Oh wait, 8 plus 4 is 12, 12 plus 1 is 13. So all the values that we added, we put a 1 below. So 128, 1, 16, 1, 8, 1, 4, 1, and 1, 1. So this gives us a binary 1001 and 1101. So now we have covered converting binary into denary and denary into binary. So time for the summary. Binary, hexadecimal, and denaries are all languages that are used by the computer. You convert hexadecimal to binary and denary into binary. If you have any queries, please write them in the comments and I'll try to get back to you. Or if you want to contact me personally, my email is on my profile picture. Now, I just wanted to clarify any a doubt that you might have. We've covered binary to denary, denary into binary. And we covered binary into hexadecimal and hexadecimal into binary. But then how do you convert hexadecimal into denary? Well, there is no way you convert hexadecimal into denary in one move. If you want to convert hexadecimal into binary, first you need to take your hexadecimal number and convert it into a binary. Then you take that binary number and you convert it into a denary. So, the hexadecimal value of 9D has the binary value of 1001, 1101, and the denary value of 157. So, see you in my next class. Please subscribe, like, and share this video. And look forward to seeing you soon. Thank you. Bye.